welcome back. This is the 8th lecture in the series on Riemann integration, and this lecture will concentrate on theorem which we mentioned in towards the end of the last lecture. And I like this theorem very much because this theorem and Merton's theorem on the Cauchy product, these two theorems illustrate what I call divide and conquer rule. And if you master something like 5-6 theorems like this, you will begin to understand how to do analysis, and in fact you can do on your own. Okay, let us get started. So theorem we want to prove is the following. Let F from AB to R be bounded, alpha from AB to R increasing, naturally it's bounded. Assume that F belongs to R of alpha integrable, okay, and also assume F of AB is contained in the interval M to capital M, okay, and let G from little m to capital M to R be continuous. Then I have a function G composite F from AB to R. Okay, we want to claim G composite F belongs to R of alpha. That is, it's alpha integrable. This is the theorem. Okay, I already said why the theorem is very useful, but anyway, perhaps if time permits, again I will revisit it after the proof. Okay, let's start with the idea of the proof. Okay, you can say in the textbooks within 7 or 8 lines the entire proof is written, but it will be very cryptic. You may not know how the whole idea worked out. Okay, let us see that. So as usual, since first we want to say it's integrable, so what do you think I should use? Riemann sum or the Darboux sum? Lower and upper and lower sums. Yes, alpha is also increasing, so that I am sure that all of you know what I would like to look at is the Riemann's criterion. Okay, is what I would like to write. So therefore we will use upper and lower sum. So with the standard notation, what we want to do, if you give an epsilon positive, I have to find a partition P such that U of alpha minus L of alpha, LP alpha should be less than epsilon, right? Sorry, this is G composite F, because we want to prove G composite F is integrable. Yeah, right. So what is this? This is little capital Mi of G composite F minus small mi of G composite F. Okay, this multiplied by delta alpha I is less than epsilon. Let us say I running from 1 to n. Yeah, okay. Now suppose this P is a partition. Let us have a look at this. So this is the partition of AB, and this is my xi minus 1 xi, right, and the whole thing is contained in little m to capital M. Okay, so where does F, so does F, right? The first thing you should notice is F of xi minus 1 to xi. Okay, this is contained in something, right? Do you understand it's contained in little mi to capital Mi? Yeah, because for any t, f of t, any t in this interval, f of t will be less than or equal to, sorry, greater than or equal to Mi, less than or equal to capital Mi. You understand? Right. Okay. Therefore, this will be a part of this thing. This will be your little m and capital M. Right. Okay. Now what do I want? And my function, this is from, now I have a G to R. Notice that by now you know that I would like to use uniform continuity of G on the interval little m to capital M, right? Okay, So what do I want? So this interval, remember capital Mi of G composite f is, look at this one, this means G composite fx and take its LUV. Where does x vary? X varies over xi minus 1 to xi. You understand? And that means LUV of G of whatever this y, where y belongs to f of this interval. Okay, which in turn is contained in Mi to capital Mi. You understand this? Yeah? Right. Now, this object is contained in Mi to Mi. As varies over this. Right. Now, what do you want to understand? So this little Mi to capital Mi, suppose by uniform continuity you gave me an epsilon, right? At present I will pretend I am working with epsilon. Then I know there is a delta positive, so that what do I know? Whenever s and t are in the interval little m to capital M, which is less than delta, should imply g of s minus g of t must be less than epsilon. Do you understand this? Right? Therefore, a capital M of G on this, G composite of Mi minus little mi G composite of, okay, this will be less than epsilon, provided I know this distance is less than delta. Right? Therefore, let's go back to our earlier idea. We already know the strategy. When I want to prove this is less than epsilon, what do I have to do? Either I should have control of this fellow, so something like this is less than something to the epsilon, and this will be finite number, delta alpha I. Even if I assume from I equal to 1 to n, that will be alpha b minus alpha a. That is a finite quantity into this. You understand? Right. So whenever I is said that little mi to capital Mi is less than delta, this term is less than epsilon. Okay, but it may not happen all the time. There may be I said that, okay, little mi to capital Mi, okay, that is greater than or equal to delta. In that case, okay, I don't have any good estimate for this object. Okay, this object I have no estimate now. Okay, if Mi minus Mi is greater than or equal to delta, okay, then I don't have any estimate for this. Then what do? I have to control this estimate. Okay, this is something like length. Okay, think of alpha equal to identity function. This is length of the subintervals for, okay, for which capital Mi minus small mi is greater than or equal to delta. So I have to somehow show that length is very small. This is a trick which we already enunciated earlier. As soon as I explain Riemann integration, Riemann criterion, I explained this trick. Okay, so what do I have to do? As I said, we have to now do divide and conquer trick. So let G equal to set of all I, so that Mi minus small mi is less than delta, and B, G for good, B for bad, right? Mi minus small mi is greater than or equal to delta. You understand? Therefore, this sum I am breaking into two things. U of G composite, I will write, okay, in a hurry I may write some such thing, but I hope you will understand what I mean. Okay, this I break it into two parts, I in capital I in capital G, so that Mi minus Mi into delta alpha I plus I in bad Mi minus small mi into delta alpha I. So what do I know? This fellow, so I'm sorry, Mi of G composite of minus Mi of G composite of, here also Mi of G composite of small mi of G composite of. Okay, right. Now what did I know? This capital Mi is Mi of f, and small mi is Mi of f, small mi of, you understand? So when, maybe I should write like this. Okay, right. So whenever that has happened, then G, okay, f gets mapped into this interval mi to capital Mi, whose total length is less than delta. Therefore, you take any 2 points S and T here in modulus, that will be less than epsilon. But what has it to do with the capital Mi minus small mi of G composite of? We will come to know in a minute. Okay, so this will be something to do less than epsilon. Okay, here what kind of estimate I have? So this will be something to do with the epsilon into summation delta alpha I running over G, plus this will be summation I over B. But what is the estimate I can have? As usual, let us assume, okay, G composite of, therefore let us assume mod Gx is less than or equal to C. Okay, for all, if you want Y in little m to capital M, right? G is a continuous function, therefore it's bounded. Therefore that will be less than or equal to some 2C times that can be taken out into delta alpha I. So if so this is some finite quantity into epsilon. So what do I want? This is also some finite quantity. So I have to say this has something to do with epsilon. If I can show somewhere it's something less than epsilon, then I would have got some positive constant times epsilon. Therefore I would have proved the integrability, alpha integrability of the composite function G composite f. Do you understand this? Okay, let us go slow, don't worry. Okay, you will see the proof is extremely easy once you understand and analyze like this. Yeah, this is the basic idea. Now how do I make sure this delta alpha I for I varying over beard, that is this the sum of the lengths of the bad intervals, okay, actually alpha length of the bad intervals can be made arbitrarily small. I want to make sure of that. That is where did we choose the partition P? For some partition. So what should I do? I have to make use of the hypothesis the F is alpha integrable. Therefore if you give me an epsilon, there exists a partition P, okay, so that's where I have the control. Okay, using that partition, choosing the partition carefully, I have to make sure my delta alpha I sum over I in B is arbitrarily small. Do you understand this? So how do I do that? So let us go slow. So again, so we are given epsilon positive, right? Now by, okay, since F is alpha integrable, okay, there exists a partition P, okay, of what? Of AB. With what property? U of F P alpha minus L of F P alpha, which is summation capital Mi minus small mi into delta alpha I running from 1 to n is less than, I can write epsilon, but me write an eta, okay, this eta I will not specify, okay, eta, okay, has something to do, okay, has some relation to epsilon, we will specify later. Okay, let's not worry about, okay, for any given eta I can do that, for any eta positive I can do that. You understand that? Yeah. Okay, now let us do that. This is all right? Okay, now what do I want to do? I want to control delta alpha I in B. This is what I want to control. You understand? The bad indices I. Okay, now let us look at this. Therefore what kind of estimate? For that I have to assume a crude estimate. Therefore summation Mi minus Mi delta alpha I running over the bad indices, okay, that will also be less than eta. Yeah, you understand? And what was, remember you gave me an epsilon, I already found a delta, okay, that is already fixed, there is no change there. You understand? And where, how did I define B? Capital Mi minus small mi should be greater than or equal to delta. That's also clear, right? Therefore this fellow is greater than or equal to delta times summation delta alpha I into 2C. Just 1 second, let me write that. Okay, yeah, so delta times summation delta alpha I is less than or equal to summation I over b of delta alpha I in mi into this is mi of f minus a small mi of f. Okay, but this fellow is less than eta. You understand that? Yeah. So what do I want? So I want to this I is over b. Okay, I want to make sure this is less than epsilon. Therefore I have an estimate for this. Sum of such alpha length of these intervals is therefore less than eta minus delta, eta by delta. Is that clear? And eta, as you say, as I said earlier, that will be something to do with are all of you happy? So this eta will be something. So I don't worry about this. Okay, how epsilon etc comes, finally I want something to be less than epsilon, we will get it. Is that clear? So I have some kind of a control. So what all it says is, you give me an epsilon, then delta is fixed. Therefore for you give me any eta positive, I can always find a partition P so that summation delta alpha I varying over the bad intervals will be less than eta minus delta. These all I have proved. Have you understood? Pause, review, proceed. Okay, now let's try to estimate the one on the good thing. G capital Mi of f minus small mi of f into delta alpha I. Mi comma G comma f. See, I am looking at this one now. U G comma f P alpha minus L G comma f P alpha. Right? This I write it as I over G plus I over B. Okay, so I want to know how to make this fellow less than something to the epsilon. Alright, now remember, over good thing, what all we know is this mi of f and small mi of f is less than epsilon. Right? Okay, therefore this fellow is less than epsilon into summation delta alpha I running over G, but that's less than or equal to epsilon into summation I running from 1 to n all delta alpha I, which is epsilon into alpha b minus alpha a. You understand that? Therefore this object, the first sum over the good indices will be less than epsilon into alpha b minus alpha a. Have you understood? Okay. Right, now let's look at the bad one. We had already done, but let me just go through it. This is capital Mi of G composed of minus little mi of G composed of into delta alpha I. Alright, but what do we know? I have no idea about this fellow. Therefore I can put a crude estimate 2c into summation delta alpha I, but that is less than 2c into eta by delta, because that's how we made it. You understand this? Yeah. So therefore what do you think I have? I have u of p alpha minus again G composed of p alpha is less than epsilon to alpha b minus alpha a plus 2c eta by delta. Yes, have you understood? Yeah. So if I take something like eta equal to, okay, epsilon times delta, you can see this is going to be 2c and delta cancel, 2c of c epsilon. So I would have epsilon times 2c plus alpha b minus alpha a as an estimate for this. Pause, review, proceed. So we more or less got the how to a complete proof. The only thing is we have to write a proof which you will find in a textbook, or if you write it in an assignment, your teacher should give full marks. Okay, if you write like this, you will not accept it as a proof. Okay, but this is actually, we have proved it. The only thing is we have to dress it in such a way that the other mathematician will accept the proof. Okay, they can read it line by line and check logically it is correct, because here sometime we may not be sure whether we are very logically correct. Okay, when we begin to write a rigorous proof, we will see that this is a rigorous proof, no doubt, but we are the kind of, what is missing is the dressing, the way of writing it properly. Okay, now we are ready. So suppose now how to write a textbook proof. You will see how many things we are going to do. Okay, so the same assumptions. I am assuming little m, capital M, small mi of f, and this I will write more often like this, capital Mi of f, which again capital Mi, and Mi of g composite of, and Mi of g composite of, etc. All have the same meaning with once I give a partition. Okay, so let us start with. So let epsilon positive be given. What is the first thing I am going to do? I am going to do, since G is uniformly continuous, and we will also assume C, that is mod Gx Gy is less than or equal to C for all y in little m to capital M. Okay, so this is the first thing. Okay, this all we will write later, textbook proof if you want to write. Okay, let C positive beside that, mod Gy is less than or equal to C for all y in little m to capital M. Let epsilon be given. Since G is uniformly continuous, there exists a delta positive such that, okay, mod y1 minus y2, merely write y minus z less than delta, implies mod Gy minus Gz is less than epsilon by. Now let's go back. What did I do here? Here when I wanted the first thing, the estimate was epsilon into mod alpha b minus alpha a. You understand? For the good thing. But what I want is the sum over the good thing. I want it to be less than epsilon by 2. So this should become epsilon by 2. So how will I write it? So here I said mod Mi of g composite of minus small mi of g composite of is less than epsilon, but I should write it epsilon by alpha b minus alpha a and half, that is epsilon by 2 times alpha b minus alpha a. So if this is less than epsilon by 2 times alpha b minus alpha a, right, so when I sum over alpha b minus alpha a will cancel, I will get epsilon by 2. You understand that? Okay, but alpha b may be equal to alpha a, because we are simply assuming alpha is increasing, but for us it means non-decreasing, therefore it may be 0. So to be very careful, what we do is so we assume it is less than 2 times 1 plus alpha b minus alpha a. Notice that these are all positive, non negative rather. You understand this? So this is the first assumption. Okay, right. So I have given this. You see, you will be surprised why I got it. Now you know. Okay, because we already worked it out why it should happen. Right? Okay. The next thing, since f lies in R of alpha. Okay. So given eta, but we know what eta I want. See, once you are given this, we already know eta must be epsilon delta, right? But I am going to multiply by 2c, that should also go away, and I want it to be epsilon by 2, therefore you will see something very interesting. Okay, there exists a partition P so that UF P alpha minus LF P alpha is less than, now something to do with epsilon thing. Let us do that. This 2c eta by delta, I want it to be less than epsilon by 2, therefore eta should be 4c delta. So maybe I want this to be less than epsilon delta by 4c. Do you understand this? See, it looks very crazy, right? How do I know this? I have to put this because when I worked out, I saw this. Okay, take it for granted. Now it's okay. So what I have achieved, I have done these two things. Now what is that my claim? My claim is for this partition P. Okay, so for any partition Q which is greater than, that is finer than P, I want to claim U G composed F Q. I may write P, but just no, do not hold me. L of G composed F Q alpha is less than epsilon. This is what I want to prove. Right, as I did earlier, I can write this as capital Mi G composed F by small mi G composed F, I varying over G plus, yeah. So once this partition is over, again I'm supposed to write a textbook proof, right? You can see I don't write it. Okay, so let G equal to this and B equal to this as earlier, set of all I, so that capital Mi of F minus small mi of F is less than epsilon, and this is set of all I, so that capital Mi of F minus small mi of F is greater than or equal to delta. So this is going to be two things. Yes, right, this is F. Okay, and we know that, therefore if I take any x in xi minus 1 to xi, then fx lies in where? Between mi and capital Mi, right? Therefore mod fx minus mod fy, suppose y is also here, mod fx minus fy will be less than capital Mi, less than or equal to mi minus mi, which is less than delta. You understand that? From that this will follow this is capital M. This, from this follow capital M of G composed F minus small mi of G composed F will be less than delta, will be less than epsilon. This is something to do epsilon by something. Okay, it's epsilon. This is a uniform continuity. You understand that? Yes. Okay, for the time being, if you want, just keep it aside. What I know is this is less than epsilon. Okay, Mi composed G. Okay, this, what did we know by our by uniform continuity? What I wanted is epsilon by 1 plus 2, 1 upon 2 times 1 plus this. Therefore this object is summation I less than G strictly less than epsilon by 2 into 1 plus alpha B minus alpha A. Just 1 second. Into delta alpha I. This is this term. Yeah, and the second term is less than 2c, because this is Mi of G composed F minus small mi of G composed F. So that's less than 2c times delta alpha I varying over B. But this is less than, we already know what is it less than. Okay, let us keep it. It's delta alpha I. Right, now we want an estimate for delta alpha I. Now we can go through it. What is delta alpha I? Okay, now since U of P alpha minus L of P alpha is less than epsilon delta by 4c, am I correct? Yeah, right. Alright, in particular summation capital Mi of F minus small mi of F into delta alpha I running only over capital B. Notice that these are all non-negative. Okay, here it's G, but they are all non-negative. This is non-negative, delta alpha is non-negative. We are using alphas are increasing, and here delta alphas are non-negative. So this is less than certainly epsilon by 4c. But remember, For I in B, capital Mi of f minus small mi of f is greater than delta. Therefore, it's less than delta into delta alpha I varying over B. So what do I have? Summation delta alpha I running over B is less than epsilon delta by 4c times 1 by delta, which is epsilon by 4c. Do you understand? And therefore this is less than, the second term is less than 2c times epsilon by 4c, therefore is equal to epsilon by 2. And this also is epsilon by 2, right? Because what is the first term? I over G. Capital Mi of G composite of minus small mi of G composite of into delta alpha I is less than I in G epsilon by 2 into 1 plus alpha B minus alpha A into delta alpha I, which is equal to epsilon by 2 into 1 plus alpha B minus alpha A less than or equal to I over all 1 to n delta alpha I, but that is equal to epsilon by 2 into 1 plus alpha B minus alpha A into delta B minus delta A. Yeah, you follow that? Yeah, but then alpha A minus alpha B. Okay, therefore alpha B minus alpha A, this is less than 1, therefore this is less than epsilon by 2, right? Therefore I have proved for any q greater than q or p or whatever it is, UFG composite of q alpha minus L G composite of q alpha is less than epsilon. So what remains to be shown is why capital Mi of G composite of minus small mi of G composite of is less than epsilon. I mean, is something whatever we wrote. Okay, please bear with me. Okay, you will see in my article all these things are textbook proof is also written. Okay, right. So there are certain observations. Let us look at what did we find. If I is in G and we said if X, Y are in R, okay, whatever it is, I do not know something. Okay, X1, if I cannot write X1, so let us say R and S are in Xi minus 1 Xi, right? Then what did we find out? FR, FS, where are they? They are in little mi to capital Mi, and this length is less than delta. Therefore what we computed is f of R minus f of S is less than delta if R, S belong to the interval Xi minus 1 to Xi. Is that clear? Right? But what I want to know is if G composite f of R, therefore G composite f of S. I want to know why the, okay, so this is G of f of R minus G of f of S, right? And fr minus fs is less than delta, therefore it will be less than epsilon by whatever the object. Okay, 2 into 1 plus alpha B minus alpha A, etc. Okay, for the timing let's not worry about this. Okay, you follow that? Yeah, therefore this happens, right? So in particular, if I take LUB of this mod G composite f at R minus G composite f at S, okay, as R and S vary over Xi minus 1 to Xi, this is less than or equal to epsilon by 2 into 1 plus alpha B minus alpha A. Do you agree with that? Yes? Okay, but what I want to claim is this number is nothing other than mi of g composite f minus small mi of g composite f. This is what I want to claim. Go back. See, this is what we did. Mi of g composite f is g composite f. Okay, this object we wrote is less than this, but what we already observed is this one, modulus of g composite f r minus g composite f s, as r and s vary over this interval, arbitrary elements of this, that will be less than or equal to epsilon. Okay, I wrote a strict inequality, but then there is another strict inequality, so do not worry about that. Okay, are you happy? Okay, this is a very, very trivial thing. This has nothing to do with function or anything. Okay, this actually I have done in my upper bounds, lower bounds, GLB LUB video. Look at LUB GLB video. I have done this, but okay, but to make it self-contained, which I usually detest, let me do it. Suppose A is a non-empty subset of R and bounded above and bounded below, as well as below and below. Okay, right? Let M be the GLB of A and capital M be the LUB of A. You understand that? Okay, now let's look at one more thing. Given a set A, a subset of A, this we can do. This also has been done in this article. This is the set of all points x minus y as x and y vary over thing. Take all possible differences. Okay, I claim that capital M minus small m is LUB of A minus A. This is a claim. You can see this is a very involved proof. That's why many times teachers simply omit it, and textbooks are very, very sketchy. Okay, let us do that. Is that clear? Okay, let alpha be the LUB. Of course, you should ask whether amount is bounded above. That is very easy, because x minus y, therefore modulus of that will be less than or equal to capital M plus capital M. Therefore, it's bounded, right? You follow that? X minus y, any arbitrary element. Okay, this is less than or equal to mod x plus mod y, but that's less than or equal to 2m. And x minus y as any x, this is always less than or equal to mod x minus y. Therefore, any element of this is less than or equal to 2m. Therefore, it is bounded above and it's non-empty because 0 is there, for example. Okay, therefore this must be what? The LUB must exist. Not only that, since 0 is already there, this alpha must also be greater than or equal to 0. Well, okay, you understand? And remember, capital M minus M must also be greater than or equal to 0. Okay, suppose, are you following? It's just a cross check. I don't require it for a proof, but you should know. Okay, so I want to prove this equal to alpha. Let us prove it. So start with any x minus y in A minus A, right? Then x minus y, see, x is less than or equal to m and y is greater than or equal to little m, therefore minus y is less than or equal to minus m, therefore less than or equal to minus m. Therefore, what do I know? M minus m is an upper bound of A minus A, but alpha is the least upper bound, therefore alpha must be less than or equal to capital M minus m. Do you understand this? Okay, next I have to prove the other way around, right? Okay, fix y in A, right? Let us look at x minus y. X minus y is less than or equal to alpha because alpha is the least upper bound for A minus A, right? Because this belongs to A minus A and this is the LUB of A minus A, right? Therefore, x minus y for every x for every x in A, x minus y is less than or equal to alpha. Therefore, for every x, but remember the keyword is fixing y. Okay. Therefore, for every x in A, x minus y is less than or equal to alpha, or x is less than or equal to alpha plus y. For every x in A, x is less than or equal to alpha plus y. So what does it say about alpha plus y? This is an upper bound. For which set of A? Right? But I know what is the least upper bound of A. Least upper bound of A is capital M. Right? Therefore, what is the relation between M, capital M and alpha plus y? Capital M should be less than or equal to alpha plus y. Do you accept it? Okay. Therefore, I have M minus alpha should be less than or equal to y. But I fixed a y, but y is arbitrary. Therefore, what does it say? This says for every y in A, M minus alpha is less than or equal to y. Right? So what is the relation between M minus alpha and A? This is a lower bound of A. Do you understand that? Right? But what do I know? Little m is the greatest lower bound of A. Therefore, what is the relation between M minus alpha and little m? It should be less than or equal to this. Right? So transfer. So I have M minus M is less than or equal to alpha, and hopefully we have proved. Yeah. Yeah. Alpha is, let us look at these two things. Alpha is less than or equal to M minus M, and M minus M is less than or equal to alpha. Therefore, what do I get? M minus M equal to alpha. Okay, pause, review, proceed. So, what have we shown now? Let us again do that. LUB of A minus A is LUB of A minus GLB of A. This is a very crucial thing which you have observed. Right? Okay. I want to go one step further. Now I want to say LUB of this is same as LUB of mod x minus y as x and y varies over A. These two sets have the same value. Okay. Bear with me. Okay, this kind of analysis is not explained very fully. Okay, usually people look at your notes and keep writing, but this you will understand this better this way. You understand? I'll put everything together to our upper sum, lower sum in a minute. Okay, why this is clear? First, notice that if x and y are in A, x minus y and y minus x both are in A minus A. Do you understand that? Because in A minus A, I can take arbitrary x, arbitrary y and take their difference. Therefore, both are there. And hence, mod x minus y, which has to be one of them, maximum of x minus y, y minus x is mod x minus y, right? This also belongs to A minus A. Because one of them has to be mod x minus y. You understand? Yeah? Yes or no? Right. Okay. So, to make your ideas clear, let me call it as something like lambda. Okay, so what do I know? This I know is capital M, LUB of A minus A is capital M minus small m, where capital M, small m are here, right? And lambda, therefore this set is a subset of A minus A. Therefore, what do I know? Lambda is less than or equal to M minus M. Are you following? Yes or no? Okay. Are you happy? Okay. I want to claim. What do I want to claim? LUB of A minus A is same as LUB of mod x minus y, where x and y vary over A. Do you understand that? Okay, right. So let us prove that. So let lambda be the LUB of this fellow. I have to prove they are the same, right? So start with x minus y in a minus a, then x minus y is less than or equal to mod x minus y, but that's less than or equal to lambda. You understand that? Therefore lambda is an upper bound of what? A minus a. Therefore what's the relation I have? Okay, capital M minus M is less than or equal to lambda. Is that okay? Right. Next, what do I have to do? Okay, now let's look at mod x minus y. This is either x minus y or y minus x. This belongs to a, this belongs to a. Yeah, yes, right. Therefore what do I know? Therefore, but x minus y is less than or equal to m minus m, and y minus x is less than or equal to m minus m. Therefore mod x minus y is less than or equal to m minus m. Therefore mod x minus y, mod capital M minus small m is an upper bound for this set. Okay, but lambda is the least upper bound of the set. Therefore what is the relation? Lambda is less than or equal to m minus m. Okay, compare these two. So we have proved this. Okay, so let me write what we have proved so far. Okay, I'll apply it in a minute. What I have shown is LUB of A minus GLB of A equal to LUB of A minus A, which is equal to LUB of mod x minus y, xy in A. Okay, please pause, review, proceed. We have proved this. So let's come back. Let's go to our I in G set. Okay, my A there is f of x, x in xi minus 1 to xi. Maybe G composite. You understand that? And what I'm looking for, my mi of G composite f is LUB of A, and small mi of G composite f is GLB of A. You understand that? So whatever we proved now, maybe I should put in a beautiful box. The box may not look beautiful anyway. Yeah, right. So what do I know? Therefore capital Mi of G composite f minus small mi of G composite f equal to LUB of this set minus GLB of this set, but that is equal to LUB of G composite f R minus G composite f yes, okay, as modulus as R and S vary over xi minus 1 to xi. Because what are the arbitrary things here? R and S I am taking. Okay, I have to take an arbitrary element here. Arbitrary element here will be, I can write it as G composite f at R, G composite f at S. You understand that? Yeah. Therefore what did I show? It is mod x minus y, therefore mod x. But for I in good, what we know is this is less than epsilon, something to do with epsilon, because fr, distance between fr and fs will be less than delta. Therefore distance between g of fr and g of fs will be something to do with epsilon. Epsilon by 2 into 1 plus alpha b minus alpha a or whatever. You understand this? Yeah. Okay, so go through the proof. So as I said, the proof is very demanding. Very rarely the proof is given in full detail. If you look at some of the standard textbook, you will see the proof will be just about 5-6 lines, very quick. Okay, a lot of details will be missing, and you will even be worried how the teacher knew something like this. For example, do you remember UF P alpha minus LF P alpha should be something like epsilon delta by 4C or some whatever. Okay, how do I know that? I would expect it should be less than epsilon, right? Something to epsilon, but it has something more complicated. Okay, how did we do that? So you will really learn analysis from this proof. I hope you all enjoyed, and don't give up. Okay, please again go through, and remember, my advice is always the same. Go through the proof, think along with me in the proof. Wherever PRP, stop it and revise it. And do not worry about whether you will remember the proof. That's a mistake all Indian students do, because they always think they should be able to remember and write in the exam. Okay, don't worry about it. You read it, and for your exam, as I keep saying, you read your class notes or textbooks. Most often you will see that you can write your own proof with this method. Okay, all the best. We will meet again.